Hi guys, so we're back for day 12. I know we're all getting sick of this, but we'll be together soon, you guys. Alright, today we're going to continue our discussion on functions, and today we're going to talk about linear functions. And as you guys can probably see in the word, it's going to be functions that make a, you guessed it, line. So in other words, functions that have a nice slope with them, and things like that. So let's get started. So as we just said, linear function is a function that has a constant rate of change, and its graph is a straight line. And if you guys remember, a rate of change, another word for that is slope. So it's going to have a constant slope, meaning as the x and y's are changing at the same rate each time. All right, so let's get to it. So as you guys can see here, this would be an example of a linear function. If I graph the points, they form a straight line. And you can see our slope each time is up 2 over 3, up 2 over 3. So it is a straight line with a constant slope. That is a linear function. All right, now let's take a look at this one. Let's see if this makes a linear function. And then if it does, find the rate of change. So 1, 5 would be, where's my pen? Right here. 2, 7 would be here. 3, 9. 4, and then as we can see, this is going to end up making a straight line. I can't fit the other points on here. And again, my line is awful. Yours would not be as awful, I imagine. So yes, it is linear. And now let's find the rate of change. As you guys can see, I'm going to make a table here. Okay. So these are my x, these are my y. As x increases by 1, y increases each time by 2. So our rate of change would be, remember it's change in y over change in x, would be 2 over 1, which is just 2. So this is a linear function up with a slope of 2. All right, let's move on. All right, 0, 0. Where's my, there we go. 1, 1. 2, 4. And then 3, 9. So as you guys can see, this doesn't really make a straight line. This kind of makes a curve. Again, I can't really, I wish I could graph better on this tool. So this is non-linear. And then as you guys will be able to see, as x each time increases by 1, y increases by 1, then by 3, and then by 5. So that is why this is not linear. There's not a constant slope. The y's are increasing at a different rate each time, so it does not have a consistent slope. It does not make a straight line. It is not linear. Okay. Does the set of pairs represent a linear function? All right, let's see. 1, negative 1, 2, 2. Why does that keep happening? 3, 5. And 4, 8. Let's check the slope. I'd go up 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. So yes, this would make a straight line, as you can tell by my awful drawing. And then the constant rate of slope is 3, or rate of change is 3 over 1, because the y goes up 3, and then the x goes plus 1. 2, so -1 to 2 is 3, 2 to 5 is plus 3, and then 5 to 8 is plus 3. So it has a constant rate of change of 3 over 1, which is just a slope of 3 because we don't need to write the over 1. All right, let's keep going. All right. Does the table represent a linear function? I know you're thinking that we would have to graph all these points, and no, ain't nobody got time for that. We're just going to look at the table. We're going to look at the changes. So my change in y would be plus 3, plus 3, plus 3, and then plus 3. And then all of these are plus 1, plus 1, plus 1, and plus 1. So this has a rate of change of 3 over 1. So it has a constant rate. So yes, it is a function, or linear, because it has a constant slope of 3. All right, let's keep going. Does the relation represent a linear function for each of these? So for this one here, our outputs go plus 2, and then plus 3, and then plus 1, and then plus, no, this is all over the place. No, there's not a constant slope here. The y is not changing by the same rate each time. But here we have, and then here, we have plus 1, plus 2, plus 3, and then plus, nope, the y is not changing the same each time. There's not a constant slope there either. So neither of these are functions. All right, let's keep going. Does it represent a function? Let's see. All right. -10 to -5 would be adding 5. -5 to 0 is plus 5, plus 5, plus 5. And then 8 to 5 is minus 3. 5 to 2 is minus 3. 2 to -1 is minus 3. And -1 to -4 is minus 3. So the y's are decreasing by 3. And then the x's are increasing by 5. So that would have a slope of -3 over 5. So that does check out as linear. Okay, we're actually going to skip over those last two. You guys are now going to head to the Pearson and do your best. And if you have questions, which I'm sure you do, I will see you on Zoom at 10. All right, bye guys, I miss you.